Welcome to your Active Tech Brief podcast. My name is Luca Bertuzzi, your technology editor. This week we take a closer look at the computing power behind artificial intelligence. For an overview on all things technology in the EU, sign up to our free newsletter or visit the website euractiv.com. This is Euractiv's Tech Brief podcast. Today I'm joined by Vili Lehdonvirta, professor at the Oxford Internet Institute. Hello, Vili.
Hello, Luca.
You have recently raised the issue in your research about the huge computing power required to run large language models like ChatGPT. Can you frame the issue for our listener?
Sure. So when we think about AI, often we just think about the applications, how it looks to us in our web browser when we're using it. But what we're not thinking about so much is the massive infrastructure behind the screen that's needed, first of all, to train these AI models and then also to run them. Let's say GPT-3, as a large language model, has 175 billion parameters. And it took something like 300,000 exaflops of computing power to train. And to put that in context, if you tried to train that model with an ordinary high-end PC, a gaming computer that you might find at home, it could take something like 200 to 300 years to actually finish training that model. And when AI developers are developing these models, they need to, train them many times over. Train it, test it, see how it performs, tweak it a little bit, train it again. And if every time you want to train it again, you have to wait 200 or 300 years, then obviously AI research is going to be very slow. So instead, what AI researchers do is they use many GPUs, many computer chips in parallel to train these models. And OpenAI is said to have used 10,000 GPUs to train ChatGPT. And even with those 10,000 GPUs, it still took days or weeks to each time they wanted to train the model. And now I just spoke with the developer at one of the big tech companies, and he claimed that GPT-4, if I remember correctly, they used 25,000 GPUs to train it, and it still took several weeks. And that's basically the issue. So the huge computing power needed to train these models, and that sort of computing power is not available almost anywhere. It's actually very difficult to access.
Thanks, Vili. There are actually a few elements to unpack there, but if I understand correctly what you're saying, the AI race, as some call it, is first and foremost a computing power race. So you mentioned that this computing power is not readily available. Who are the main actors active in this race?
Yeah, well, let me just comment on the AI race. What is the race about? Well, AI stands on three legs. One is data. The other is algorithms that developers create. And the third one is compute. And the public debate is dominated very much by data. I also was very much focused on the issues related to data and data governance and data access and data protection until I started talking to actual AI developers. And I remember distinctly this time when one of them explained to me that, well, no, data is not really the bottleneck. There's lots of data, there's open data sets. Scraping the entire internet is actually not that expensive. The real bottleneck is compute. It's the computing power required to actually train the models or the algorithms using that data. And so as to the question of, well, who are the main players? Who has that compute? Actually, only 3 companies have a most compute in the world. One is Amazon with its AWS cloud computing platform. The other is Microsoft with its Azure cloud computing platform. And the third one is Google with its Google cloud computing platform. And these companies have massive data centers with tens or hundreds of, up to 100,000 servers in one data center. And they have these massive infrastructures because obviously they have large demand for computing thanks to their own operations. They are all big internet companies, but also because they are in the public cloud business, which means that they are selling computing power and data storage to lots of other companies. So most of the popular websites that you will visit and most of the popular apps and digital services that you use, they actually run on AWS or a similar cloud computing platform. And thanks to that, these companies have this massive capacity, massive reservoir of compute, which can then be used also to train AI models. No ordinary startup or even mid-sized company has anything like this number of GPUs at its disposal.
That's very interesting, Vili. So you mentioned 3 big tech companies, American companies that are, of course, the leading players in the cloud market. In Europe, there have been a lot of discussions about digital sovereignty. So how can EU companies or the EU at large compete in this context? And what about, economic powerhouses like the United States and China? What role do they play into this?
So indeed, big 3 leading cloud computing powerhouses, they are all American. Then there are some large Chinese players as well. Alibaba Cloud is a big cloud computing platform, which can also be used to train AI. And interestingly, the US, as you know, is trying to limit China's access to the kind of high-end computer chips which are used to construct these data centers, which are used to train AI. So there's a whole sort of supply chain of very physical goods that is powering AI development. And the European countries, as you say, they sort of find themselves sitting between these 2 digital superpowers and wondering about their own digital sovereignty. If we're dependent on 3 foreign companies for all of our compute, then how autonomous or sovereign, if you will, are we actually? And one of the ways in which European countries are trying to address this now is by building actually publicly supported or publicly funded compute capacity. For instance, here in the UK, just very recently, the government announced a £900 million investment into building a national AI compute capacity. So they want to invest £900 million into building a public computing capacity that AI researchers could use, and they wouldn't have to resort to partnering with either Amazon, Microsoft, or Google. But the problem is this £900 million really doesn't go very far. It's a tiny fraction of what these big American tech companies are investing into cloud computing all the time. Google alone invests about twice as much into R&D as the entire UK government. So it just doesn't buy the necessary amount of compute to compete. A recent report, UK government sponsored report, suggested that the UK should buy or create a national public AI compute capacity consisting of 3,000 GPUs. But as I mentioned, ChatGPT was trained using 10,000 GPUs, and even that is now old news in the rapidly developing world of large language models. Now you need something like 25,000 GPUs to train the cutting edge models. So the UK government's 3,000 GPUs is just not big enough. And the same problem faces France and Germany. In both France and Germany, there are efforts to build national or trusted or sovereign cloud computing platforms, not just for AI compute, but also for things like government data storage and hosting public sector services. But they tend to lack the scale necessary to actually achieve those efficiencies of scale and that scale of investment that the American platforms have, and therefore they fall short of the American platforms in features and in capacity, and therefore people end up in companies and researchers end up using the American platforms anyway. So, then if you ask, well, what can be done about this? I think that one direction that European governments increasingly are looking into is, well, we need to have some kind of collaboration between countries. Now, obviously, it doesn't make it any easier that the UK is no longer in the EU. But certainly, countries that care about digital sovereignty and having some kind of a national capacity to develop their own AI models and not have to rely on foreign companies for that. Certainly, they are increasingly interested in the possibility of, well, can we cooperate over this? Can we pool our investments and that way reach the necessary scale?
It's quite telling also that we are talking about collaboration in order to reach digital sovereignty,
Yes.
which
that's interesting. It's almost like an oxymoron, yeah. Yeah, you have to
yeah,
pool some of
exactly.
your sovereignty. You have to pool some of your sovereignty. You have to give away some of your sovereignty in order to actually reach sovereignty. Yeah, there's a little bit of a
Indeed.
tension or a contradiction. But you see, it makes perfect sense because according to one theory, the purpose of government, the purpose of state, is to provide public goods for citizens and businesses. And that implies that the minimum viable size of a sovereign state is such that it is sufficiently large to efficiently provide public goods to its citizens and businesses. And what is that minimum efficient scale? It varies through history. It depends on technology. So if we have now entered an era in which the minimum efficient scale to provide digital public goods that society depends on is larger than the boundaries of industrial era countries, then that quite naturally leads into this pressure towards political integration and unification. Or if according to this theory, basically, if you resist that trend, then you lose out in the race, and that way the sort of efficiently sized political units triumph over the insufficiently large ones.
Indeed, but going a step back, is it even possible? I know we're just getting started on this, but is it even possible to catch up? So, for example, if you take very successful AI models like ChatGPT, they are being used to train even more powerful algorithms. They are collecting millions of data points that then feed into future algorithms. At the same time, computing power takes a long time to build up, and it's very expensive. And you basically need also a business model, as the cloud hyperscalers show. So, how will all this interdependency play out in the long run in terms of getting a head start in this international race?
Well, so I have both a pessimistic view and an optimistic view, and which one is correct? We're still at the kind of beginnings of researching all this, but the pessimistic view is that there is a sort of path dependency or knock-on effect from one technology to the other. So the giant tech companies, US and Chinese tech companies, success in the platform business, in social media and online marketplaces and so on, gives them access to large amounts of data. It gives them access to large amounts of compute, and then that advantage is then repeated in the next technology, in AI, and so on and so on. So they will, according to this view, it's very hard to break this cycle because dominance in the previous generation of technology gives them an edge also in the competition for the next generation of technology. Then AI is being used to help research and develop the next generation of technology, whether it be space or whatever. And so this is the pessimistic view. But on a more optimistic note, in real life, there is no exponential growth or development. There are only S-shaped curves, sigmoid curves. When we are seeing rapid development, rapid advances in AI around us, and we extrapolate from those observations into the future, and we see this tremendously fast pace, and we can't imagine how we could ever catch up with that. We forget that at some point that pace of change will slow down when the easy wins have been won, when the low-hanging fruits have been eaten. Let me use an example from a previous AI technology. 5 years ago, everyone was talking about self-driving cars. Self-driving cars were supposed to take over our streets. Has that happened? No. Why were the predictions so wrong? Well, in my opinion, it's because people were observing improvements in self-driving car technology. They could see that we had rapidly progressed from 0% self-driving to cars that could maybe 10% drive themselves, 20%, maybe even 50% of the time. And they extrapolated that, well, at this pace of improvement, we will reach 100% in just a few years. But what they forget is that, of course, always the development starts from the easiest problems. And so after the first half of the problem is solved, then we have to face the more difficult problems. And the last 1 or 2% are those almost impossibly difficult challenges. And therefore, what initially starts as a very rapid improvement slows down as it progresses, and at some point basically grinds to a halt. So in the same way, taking those lessons now to generative AI and large language models, very recently we've seen rapid improvement, and we are extrapolating from that into the future and expecting that 1 year from now we will see something absolutely incredible if this pace of change continues the way it is going now. But in fact, there's already signs that the current paradigm of research and development in large language models may be starting to reach a plateau. Because I mentioned that GPT-4 was trained with something like 25,000 GPUs, and because every time you increase the number of parameters in the model, the complexity of the model grows super linearly, and you have to use a significantly more computing power than before. But the problem is you can't just keep adding more GPUs infinitely, because the interconnection overheads from these GPUs communicating with each other increase with the number of GPUs. So at some point, the marginal benefit from adding additional parallel GPUs is entirely sort of countered by the marginal cost of the additional interconnection overhead. So what I'm getting at here is that the current paradigm may be reaching its plateau, and this type of technology may become increasingly commodified, and the action and the excitement and development may move on to another type of technology. And if that's so, then it is possible for countries in Europe that are currently not leading in AI development to catch up with this type of AI development, since the pace of change slows down. Those access to the GPUs improves. The technology becomes more commodified, becomes more commonplace, and so on. So according to this more optimistic view, it's more of a temporary setback, and once development slows down, then Europeans will be able to catch up again. Now, whether this optimistic view is correct, or whether the more pessimistic view is correct, according to which then even in that next race the previous winners will always be advantaged, that's that's still up for research.
Thanks, and I really think that we can use a word of caution about all this enthusiasm that we are experiencing about AI at the moment. But I do tend to agree more with your optimistic view, and I will explain why. Indeed, what we have seen since the internet has become so omnipresent in our lives is that big tech companies tend to use their market power to leverage it to conquer more and more digital markets. But that is the current paradigm. If we look at before the years 200s, the main technology companies used to be telecom companies, but right now they're nowhere on the radar of the biggest players. So, as you said, this is the paradigm that we are looking at now. And if we look at very impressive models like ChatGPT, Midjourney, these, as you said, are all based on very powerful supercomputers. What will happen when AI will be powered by quantum computers? Will that be perhaps the paradigm shift in this race?
That's a good question. So I really can't say much about that other than to present a few guesses. I mean, one guess is that it appears that quantum computers could be uniquely suited to training certain types of AI models. And if that's the case, then and if the build cost of quantum computers of that capacity is actually lower than the cost of having a massive data center full of GPUs, then that could sort of democratize access to AI training. So that's one possibility. And obviously, EU is not doing bad on supercomputer development. There is a leading supercomputing firm in Finland, for instance. On the other hand, quantum computing is something that has been promised to bring breakthroughs already for quite some time, and it hasn't quite redeemed those promises yet. So it remains to be seen when and to what extent these promises actually turn into reality. So that's the word of caution. When we think about ChatGPT and Midjourney and so on, and we are worried about their potential misuses, such as, could ChatGPT be used to spam the internet, create lots of fake content, and so on and so on. This is one concern that people have, and maybe something that is forgotten in there is that it's not just training the model, but actually also running the model, what the computer scientists call inferencing, that also takes lots and lots of computing power. So for that reason, when you're using ChatGPT, you see the words appearing slowly because it's actually using lots and lots of computing power in the background. And that computing power has a cost. It costs electricity. It costs in capital costs to actually keep all that computing power available there. So it's not like it's free. And in fact, it might even be cheaper to use low-paid online sort of click workers to produce this kind of different kinds of spam content or just different types of content than it is to actually run a high-end large language model. Or at least the difference in the cost is not orders of magnitude. In both cases, we're talking about some number of dollars per hour. So it's not the kind of situation where suddenly producing text and producing original content is zero cost. If that was the case, then yes, that could really upset some of the ways the internet works, because now suddenly at no cost people can produce lots of content, whether it's social media messages or political opinions or Facebook posts or reviews on e-commerce websites. If those could all be produced at zero cost, then that could certainly change a lot how the internet works. And we are kind of used to expecting this sort of revolutions brought about by the digital, where something that used to be very expensive suddenly becomes very cheap. But at least so far, large language models are actually not that kind of a revolution, because actually running the model involves a non-trivial cost that is comparable in magnitude to what it costs to hire a click worker in a low labor cost country and have an actual human produce that content, as happens today.
Vili Lehdonvirta is professor at the Oxford Internet Institute. Thank you, Vili. That's all we got time for this week. Don't forget to sign up to our free Tech Brief newsletter to stay on top of tech news and digital policy developments in the EU and beyond. Also, don't forget to subscribe to this podcast, published on Apple Podcasts, Spotify, Stitcher, and Amazon Music. This episode was produced with the technical help of Evi Chiori. I'm your Luca Bertuzzi, and thank you for listening.